Every HVAC technician knows that 1 TR equals 12,000 BTU per hour. But have you ever wondered why it's exactly 12,000? Why not 10,000? Why not 15,000? The answer takes us back to a giant block of ice. First, let's look at what a BTU actually is. We have already explained the concept of BTU in great detail in a previous video, and you can find that link in the description below, so definitely check it out. For now, let's cover the basics. Back in 1840, a specific unit was discovered to measure heat, and that unit is the BTU. To understand it, let's take 1 pound of water, note its temperature, and then apply heat to it. If the water temperature rises by 1 degree Fahrenheit, it means exactly 1 BTU of heat transfer has occurred. Essentially, the amount of temperature rise tells you how many BTUs of heat have been transferred. Conversely, if heat is removed from the water, the drop in temperature indicates exactly how many BTUs of heat have been extracted. This should give you a solid basic idea of what a BTU represents. Next, let's break down the basics of TR. We define a 1-ton ice block as 1 TR. In other words, the amount of heat a 1-ton block of ice can remove over a span of 24 hours is the exact same amount of heat a 1 TR AC unit will remove. So, in this context, 1 TR is directly equivalent to a 1-ton ice block. We have also uploaded a highly detailed video covering TR and its history. The link is in the description for anyone who wants to check it out. Scientists determined that melting 1 pound of ice requires approximately 144 BTU of heat. To visualize what 144 BTU looks like, let's perform a simple water and ice example. 1 US short-ton ice block weighs 2000 pounds. Let's take just 1 pound of ice from that block. Now, imagine a closed, conditioned environment where we have 9 pounds of water. Let's note the starting temperature of this water, which is 48 degrees Fahrenheit. Next, let's drop that 1 pound of ice into the water. We will wait until the ice melts completely, and the moment it is fully melted, we will measure the water temperature again. You will find that the water temperature has dropped to 32 degrees Fahrenheit. As we established earlier, if the temperature of 1 pound of water drops by 1 degree Fahrenheit, it means 1 BTU of heat has been removed. Therefore, if the temperature of 9 pounds of water drops by 1 degree Fahrenheit, it means 9 BTUs of heat have been removed. In our scenario, the temperature dropped from a starting point of 48 degrees Fahrenheit down to 32 degrees Fahrenheit. Subtracting 32 degrees Fahrenheit from 48 degrees Fahrenheit gives us a total temperature drop of 16 degrees Fahrenheit. Since a 1 degree Fahrenheit drop in 9 pounds of water equals 9 BTUs, then for an 16 degrees Fahrenheit drop, we multiply 16 by 9, which equals 144 BTUs. This means that 1 pound of ice removed a total of 144 BTUs of heat from the water. Following this math, a full 2000 pound block of ice will remove 2000 times 144 equals 288,000 BTU per day of heat over an entire day. To break this down by the hour, we divide 288,000 by 24, which gives us exactly 12,000 BTU per hour. And that is precisely how we establish that 1 TR equals 12,000 BTU per hour. To make this easy to grasp, I have simplified the explanation for this video, but in real life, you only get these exact readings when the calculation is performed under highly controlled and precise laboratory conditions. If you found this video helpful, please give it a like, share it with anyone else who might find it useful, and make sure to subscribe to our Zebra Learnings channel. Thank you.